Interesting.
Can't be like, okay, okay, that's log E of X is less than zero.
Remember the last time we like that here?
It's something with power of zero is just one.
No,
Log of E to the X is less than zero. Pretend that's an equal sign, then it's E to the zero equals X.
Okay. 10 seconds.
But like less than zero, it could be one over E. Oh wait, no, that's less than. No solution. No solution. Because if you write it out, it goes log of N to the base is less than.
Okay, folks.
Right.
It's a quick warm up. I like to get through the lesson pretty quickly so we can get to the good stuff, the quiz.
It's never less.
So you've had some time to think about it. I'd like to hear from the one and only Miley. What do you think? Never? Okay, why? It's what? Okay, so if you think of the graph, it's not less than zero. Yeah, I see what you're saying. Elle, what do you have to say about that? X is less than 1. Why do you say that?
The base of both E, like Ellen, so that would get X
So you kind of did this or something? Okay.
is equal to one.
Okay, I think it's a really good idea. That's a great way to solve equations. A little scary to solve inequalities, which is probably why you felt like, is this right? So it's not a bad idea, and I really like you bring that up. Simran, did you have an idea that you'd like to show
Oh,
us?
well, yeah. I just remember like when we first started learning like logs and stuff, I remember like somebody asked a question where it was like if it's like base can't obviously has to be greater than zero and can't be one. But then
Okay.
like somebody asked if like is it the argument
Oh, nice. Yes, I do.
can't be negative.
Okay.
And so even if it like I wrote it kind of like what Elle did, I did log base E to like of X is less than zero. Like if that were to be an equation, like no matter what X is, like it's just impossible.
Okay.
Like if like you had like E to like zero, it's always gonna be one.
Okay. Okay, so I think Miley, I think that jives with what you were saying. Okay. Yes, Jonas?
I disagree. Because
Okay.
if you have log base e to the log base e to the e to the 1/2, which
Log base E of 1/2. Okay.
log base e of e to the 1/2.
Oh, of E to the 1/2. Okay. Like that?
That would be no.
E to
E to the -2. Yes. E to the -2.
Oh, E to the -2.
E to the
Okay.
-2, that would equal -2, and that would be less than 0.
Ah,
So therefore, it's when x is greater than 0, but less than 1.
interesting. Yeah, Connor, do you want to piggyback on that?
Wait.
Oh, controversy. Connor's been very patient with his hand up. So Connor, and then if Max still wants to talk, then I'm sorry, if August wants to. Yes.
Me and Jonas came to the same conclusion in different ways.
Okay.
Look at the log graph.
Okay.
The x-intercept is going to be 1,0. And then after that, all the y values are going to be negative. So
After that?
what-
Okay, so kind of like this.
something like that.
Okay.
No, there's
Something like this, except really, that's a really terrible job. That's kind of like a joke, isn't it? Yeah.
Well, but the sign is still the same because the y values are going to be negative. So when x is less than 1 and greater than 0.
Oh, what do you guys think?
That's so true.
Yeah, I like how you're just looking at the graph of L and of X. That's what it's about. That's what it's about. So for which value of X is this function less than 0? Do you see that when X is between 0 and 1?
Oh.
Now, of course, it's true. X is less than 0 is a problem, but we're not talking about X being less than 0. It's just asking when is the function less than zero for what values of x? And that happens in that small window between 0 and 1.
We should just draw it.
Drawing it is never a bad idea to get some insight. Would number line analysis have helped with this?
Yes. Sorry.
I don't think I think this is the most direct. It's like, what would you do with a number line? Think about the graph, wouldn't you? Isn't that how it would work? So I think it's just go to the graph.
Can never be negative, right? The
Argument can never be negative.
Okay.
That's a really good argument for that. Good.
Thank you.
Nice. Yes, L?
I don't know how they work. It's just that you.
It's scary. And it does. So you said e to the ln of x is less than e to the 0, basically. Leaving us with x is less than 1. So this doesn't keep in mind that x has a limited lifespan. It's just like, yeah, we lost something with it. So algebraically, we got something important though, didn't we? Yeah.
They locked.
Yeah.
I'm sorry. Okay, well, me and Nathan are locked in too.
You guys were not.
I feel like there's a lot of locking. This is great. Okay, let's get on with today's stuff. I think you're gonna like it. Are you ready for this? You're gonna love this one, I'm sure. I was thinking about when I was looking at the lesson, like I'm just gonna love this lesson. See, I knew it. Okay, yeah, not as excited as Connor, but that's a tall order. Okay. Okay, so we are today starting on page 10. We're finishing up last time. Last time we talked about exponential and logarithmic equations. Today we're doing logarithmic inequalities. We're going to do that, and then we're going to do a little bit of statistics.
Last day.
No, there's still one more day and then review. Yeah.
Today's lesson going to be on the quiz? No, it's not.
Oh, well, not. Yeah. Maybe some of the stuff, but none of the new stuff from today will be on the quiz. And also the homework, because I always forget to say, homework is from their packet, and it's going to be 2.14 for your packet, just so you know. Homework packet, which is on the hub if you don't have access to it readily. What's that? Oh yeah, the blue packet. Thank you for reminding me. Okay, so example 5. Now I do want you to change your problem so it looks like this, please, for example 5 on page 10, I said, is that right?
Yeah.
The question is asking, what are all values of x for which g of x is less than h of x? Okay, so g of x, that is ln of x squared plus x minus 6, and I'm wondering that's less than ln of x minus 5. Should I just raise both of these? Should I make them both e to the that? Not for inequalities. That's a really good way to solve equations, but inequalities have to be careful. So instead of raising anything or making these powers, I'm going to
Factor.
divide by ln. Is that maybe?
No, maybe.
That's not a thing.
But you can never divide.
We've never heard of
Move it to the same side.
Yeah, let's move everything to the same side. Let's not.
Then you
Let's
can.
go. And then we can do something. Let's see. I think factoring is in your future. See? I knew you'd love it. I knew you'd love it.
They're gonna cancel.
I can't say maybe. But not, yeah, never. Haley,
Can you never, I guess, raise it to the, exponential like that?
it's not about being exponential. It's the fact we have inequality, so we have to use analysis. And I'll talk about exactly what this means. Of course, that left side, we're going to consolidate that into a single logarithm. Make it ln of.
Cogs are turning right now.
Right on the bottom of this fraction is
Nice spot.
x minus 5. Nice. And on the top, should we just do some factoring? Because we're going to anyway. X plus 3, x minus 2, and all that is less than 0.
Let me down.
And I'd like for you to discuss, don't write anything down, discuss what's the next step after you've written this down. Where do you go from here?
Now we can do a number line.
And then if you put in E. It says like, look.
So.
Yeah, and then that would be one.
Now.
Anything zero is one.
You know,
Put it, we put it the number. As the exponent. Wait, ready?
Figure out.
Wait, now we put it, wait,
Don't write anything yet, guys.
wait, now we, I think now we.
Yeah, now we need to figure out. Okay, so we know
So X plus
negative
three.
Don't write anything is.
Oh.
Okay, I need some direction. I also need to point out that I've written to the left very specifically because this is gonna take a lot of work. I'm sorry, I didn't warn you about that earlier, so it's gonna take a lot of work, so I put everything on the left very intentionally. So you're probably gonna want to move your stuff over to the left. But before that, I want an idea. Where are we going from here? Someone who hasn't given us an idea yet. Goes first. It's first choice. Yes, Emma. So we'll make E right here and here, right?
Yeah.
Elle, what do you think about that? E here and here? Should we do that? Why not? Why is it dangerous? There's information. Yeah, this is not, it'll be perfect if it's an equation, but this is inequality, so we need a different way to do it. But thank you for thinking of that. But no, someone who hasn't given us an answer yet. Any other ideas? Yes, Haley. What would you do with the number line?
Like, the natural log kind of messes me up, but
Right.
would you like put in like 5, -3, or would you have to like count? I don't know.
Did anyone else suspect that there's a number line in our future? Good. There's a number line in the future, but not yet. Let's wait for the right time. Nia, you have an idea?
Zero is less than x plus 3 times x minus 3 over x minus.
Also, just change it to exponential instead of like raising both sides. That would be a really good idea if it's an equation, but we lose the whole, like, which one is less than if you're rewriting everything, right? It becomes unclear. So we're gonna hold off. Okay. Connor, you've been very patient in the back. What do you think? You have an idea here?
I'm not if I want to.
Oh, did it? Interesting.
Yeah, so we know that the argument
Mhm.
has to be less than 1, greater than 0. For y equal, for y to be less than 0.
Wait, let's process that. Does that make any sense? This whole thing has to be between 0 and 1, so that ln of that
Yeah.
mess will be
Less than
No,
0.
because you know.
less than 0. In other words, negative. So, thank you. Good connection. Yeah, so we're just gonna take this x plus 3 and say exactly what Connor just said. It has to be greater than 0 and less than 1. Does that make sense?
Less than one, I thought, doesn't the argument have to be greater than 0?
Well, think about the graph of ln of x. In that window from 0 to 1, just for the warm up. When all of this is between 0 and 1, ln of that stuff would
Oh, it's gonna be less.
negative, yeah. So we're looking at that little tail of the graph of ln of x in our mind. But obviously this is not ln of x, this is ln of craziness. But the craziness has to be between 0 and 1 still.
Just
Connor,
as
good
a-
catch. Yeah. Exactly, as a rule of thumb.
Zero and one, it's gonna be negative
It's
outside.
gonna be negative. So what I'm gonna do, I'm gonna help you with this by making two different problems. I'm gonna say that first of all, 0 has to be less than x plus 3, x minus 2 over x minus 5. Do you know what my other problem is?
Same thing, but less than 1.
And yeah, the same thing. And I'm gonna write this separately because algebraically, that's how it works out. I messed up. That's x minus 5, isn't it? Has to be less than 1. I give you a moment to first solve this one. Check with your neighbor. And I'm gonna give you a note here.
Yeah, number line.
You can read it later if you'd like. I'm gonna make it a silent note, so I'm gonna put a very big tip for that second one.
Five is the.
Okay.
Okay, the denominator, right? Wait, don't-
Simran,
I'm, I'm sorry.
why can't we remove denominator?
You have to do the
Numerator
number.
is all that.
You know, I'm good with a guessing check, shall we?
Wait, hold on. Okay, so
I don't
when is
see
it?
why you.
So now basically that's the regions,
Oh,
right?
you're
X
right.
can't be five.
That's
So
the
like
region.
do like zero, let's start with zero.
Okay, so zero, it's gonna be
Three.
negative on the top
It can't be two, it has to be three.
and negative on the bottom, so positive.
Well,
So
that-
here it's positive
Wait,
and they're all multiplicity.
I don't understand why the denominator would be other,
But
like a numerator type.
negative.
And when is it less than zero?
It's not even.
It's less than zero in these regions.
No, I.
What about-
Oh my god, I got it. And then we see which ones are in common. So now let's subtract the other one.
Yeah.
Oh,
Here's this is and.
that's genius.
Which one's
Oh,
on?
yeah. Method.
Okay.
Really so much better than this.
Yeah.
Yeah. Ready? And then negative three. Oh my god, Mr. Lieberman, I think Nathan and I cracked the code.
Or we're.
Oh, that's exciting.
did.
Just like.
That's exciting.
That just could be really wrong.
Okay, wait, let's test our region. Ready? Wait, they're the same equation. What is that? Where is it less? Less than one. Okay, so zero, if you plug in zero, we have to add. Okay.
Are you doing the P's and Q's?
Negative six over
No.
negative five. Negative six over negative five is less than one.
Yeah,
Yeah.
yeah.
Wait, no, is it?
It's negative.
No, no, negative six over
Oh,
negative
yeah,
five is
it's
six over five is greater.
So that's if it's zero.
Yeah, so zero.
So then this is out.
Oh, look at me.
We cracked
Yeah, I don't think we do.
Maybe we didn't crack.
Do you get the first answer, the first set?
We got the first set.
Okay, now let's
Wait,
try
let's
like.
write down.
three.
Haley, what strategy do I have to use for that first? Are we good with the number line?
Yeah.
Got a number line, and then we have to place some boundaries. The first boundary starting on the left is -3. Then we have 2 and 5. Does anyone already have this?
Got rid of the five.
You got rid of it? Oh, did you multiply both sides by x minus 5?
That's actually. I left it on there.
Let's talk about why you can't do that. If you had x plus 2 over x minus 4 or something like that, then the question is asking if it's greater than 0, right, Elle? We're asking if it's greater. This is separate. Now, if we said it's equal to 0, then you can multiply the x minus 4 all day. Wouldn't be a problem. But here, we are checking to see if this is positive. We have to consider is when the top is positive and the bottom is positive, or when the top is negative over negative. Right, so multiplying through would lose that for the inequality. We need to analyze everything that's going on. So we can't do that when things get a little bit more complicated. Like here, we have to keep all 3 boundaries. Now, inside these boundaries, there are regions. We're going to plug in 0. Are you sure you want to plug in 0? Me too, except as a score. That's it. That sucks me. Yeah, but you wouldn't know. Yeah, I do. I won't tell you, but okay. So we plug in a 0 and we see that results in
6 over 5.
Positive.
positive. What we care about is positive. 6 over 5 specifically. So right here it's positive. Is this going to take a lot of work from here? It shouldn't. Everything's multiplicity 1, so it just alternates. And for all these, I'm going to put nothing there because all I care about is when it's greater than 0. So none of them satisfy. I don't care about it when it's equal to 0. I'm not going to differentiate between asymptotes and zeros. So my answer so far is
-3 to 2.
-3 to 2 and 5 to infinity. I hope it makes sense also that this right now is the domain, right? Any other values of x would result in catastrophe because if you plug in negative numbers in the argument, who wants to do that? Not Emma. I know that for sure. I don't know about the rest of you, but I suspect you're on board. So I'm just gonna put like some boxes. Like this is where our world is for this problem. What do you think? Does that make sense? Okay, for this next one, I said we can't multiply both sides by x minus 5. Just not for the inequalities. Just please don't. I think we're at Jonas. I thought that's a double stretch, double hand raise. Okay, Connor, yes. Mhm. How? Okay. Mm, okay. Okay. Well, the problem is there's how many different numbers in here?
Infinity.
There's infinitely many numbers in here. So we might find some that are less than one, some that are greater than one, but I'm not sure that there's a justification to say that all of them behave the same. You have an idea?
1 to the left side, and then combine it with existing like this stuff. Excellent stuff.
Okay, so when you subtracted one, that was in the form of x minus 5 or x minus 5. Right now, we can see the positive, negative behavior. I'll let y'all finish this. Thank you. Yeah, that's what we need to do. We need to move that one over. Because for inequalities, it's got to be, this is a positive, is a negative. That's what we care about.
So we just took the old equation and subtracted the 1.
Yeah. That isn't that what it's saying?
Yeah.
That's to solve that.
Yeah.
Notice I.
Wait, Nathan, I can put that on.
For one,
No, you're not.
Like.
alright, so basically,
Oh, we're solving.
I see my own.
Okay, ready?
3 times
X
Emma, is this lesson living up to your expectations?
I need to put it when 5.
plus
X squared plus 2x
minus x minus.
plus
Why do
1
we-
Oh,
minus 1
yeah.
over x minus 1. Okay, let's graph this, Nathan.
Wait, what's the final?
This one. Okay, let's graph.
Are you sure it's x for plus 1?
Yeah, because it's x squared plus minus, no, you're right. It's x squared minus 1. Which is just x minus 1 squared. Yeah, that's not. It's, yeah.
So what do we graph?
Okay, x minus, yeah.
Good question. That's why you have August there.
It's subtraction. Yeah. Okay, wait, so if x squared, ready?
We're gonna graph it.
Minus 1
Why did you get back?
over x minus 5,
we
which is
moved the
x
one
minus 1 factor. Yeah, x minus 1, x plus 1.
And it's the same thing as x minus 5 over x.
Roll back.
Yes.
Have not gotten the one.
Technically, it's x plus 5, because it's like the negative.
So on the bottom is x minus 5, top is
X minus 1,
x squared minus 1 is, oh, that's kind of nice, isn't it? So on the number line, I still have 5 plus or minus 1. Okay, and when we check 0, we find that the result there is positive or negative. Just positive here, as we're going to alternate back and forth. Okay, so we're looking for when this is positive, which is right here, and when this one is.
That's right, we just like.
I messed up.
No.
Excuse me.
No.
So we have to figure out this one. So we have to kind of figure out when both are happening. So would it make sense for me to maybe get rid of this and put the number line just directly under? Yeah, pretty big number. And I'm just gonna line it up so everything matches. I'm gonna remember that over here is negative, positive, negative. Would you just check with your neighbor to see if they get the final answer?
Got it, John.
When is it greater than zero?
Negative one to one.
From negative one to one? Why not?
Now we're writing the domain to that. Yeah.
Both.
Negative negative one.
No, wait,
On the
what?
box, really? Why?
I think we'll have to do that.
Should be less than.
Yeah, what are you doing?
Wait, it
You
needs
see it?
just needs to be less than zero. We can write negative infinity to negative one, comma, 1, 2, and 1, 5. Yeah, yeah, we got it, I got it. Negative infinity. Oh, yeah. To 1.
Oh, so you can back.
No, to negative 1. Union. Yeah, we. 1 to 5, but 5 is not included. Good job, thanks. There is no that.
Okay. So, would you please show me, well, who'd like to tell us the final answer? Yeah, Simran.
We got negative infinity to negative 1, but the negative 1 is included.
Okay,
And then, we did union, and then 1 included to 5 not included.
like this. Okay, are we good?
Wait.
What was the point of matching it up
I
with the
got
other one?
Oh, what's the point of matching up with the other one? It seems like this was not considered, was it? Well, it's a good starting place. Good starting place. Emma, yes, what do you think?
Which parts so overlap.
Ah, okay. And you recognize that they're both valid from, do we agree? Because remember, this is an and problem. It has to qualify this first one and the second one.
Second one being like the one that's
The
left.
second, yeah. So it is from -3 to -1. It's not included.
Wait, what about?
Because if you plug in, like if you plug in a -3 for, so I get
Are we doing
0. You can't plug in a 0. Yeah. Really? Oh, because it's from our original hypothesis that for this to be less than 0, this has to be greater than 0 and less than 1 is in that range.
Wait,
This was a whole lot of information. I'm gonna give you a minute to talk it out with your neighbor and make sure everything is ironed out.
why did
What are we? Where are we doing that?
for where they're both lower than 1, so you need.
Oh.
Maybe
That word.
Wait.
10 more seconds. Okay, so I'm curious on a scale from oh my God, this was terrible to this is the most incredible thing I've ever understood. Where do you feel like you are in terms of understanding on a personal level? Okay, it's kind of all over the place. If you don't understand it, I do urge you to give it a little bit of time. I'm going to post it online if you want to re-listen or talk it over. If you want to come by and talk to me about it, I'll definitely do that. Any questions? Perhaps your questions, can we try another? Unfortunately, there's no time for that, but example four is a pretty good one to try on your own later. But we have to do some other work. Okay?
Quiz done.
It's definitely not quiz time.
Oh, that's. Yeah.
So let's say we're taking a sampling and you found that the data lined up like this. You know, obviously that this is quadratic, yes? And not quadratic. Logarithmic, doesn't it look like logarithmic? Yeah, so when it grows like when it's grows slower and slower, in other words, concave down, we're dealing with something that's logarithmic, potentially. Okay, so we're going to work on making some logarithmic models. And I'm going to start that here by saying, okay, well, we have these 2 points, 2, 5, and I'm going to make a really general graph of this. And sorry, 2, 3, isn't it? And plot points. 5, 7 is like up there. Now, if we just had these 2 points and that's it, you'd probably assume that the growth is linear, wouldn't you? If that's all you had. Now, could you imagine a world where these 2 points are part of an exponential function? You can imagine that, couldn't you? With that, can you show what that graph would look like?
Right?
If it's exponential, it's growing. It's exponential growth, so like a slide going upwards. Yeah, but this one is saying that it's logarithmic. So could you imagine what the function is looking like? Yeah, the logarithmic function going through here. Yeah, exactly. Like an upside down slide. Something like this. Yeah. So our goal first is to make that equation. I know it's gonna be so exciting. So this is saying to use, and logarithmic modeling will always be either in this form, and this is what we're gonna use for this one. Or you can see it might just be a common log. In this case, we're using ln. Yeah. So notice that a plus b ln of x means that we lose that y-intercept, the x-intercept. We're used to the x-intercept being 1, 0. But with that plus a, it's either moving up or moving down. So it's not locked into that 1, 0. You can't assume that the x-intercept is 1. Okay, so let's figure out exactly what the equation is. It says use the given data to write 2 equations that can be used to find the values for constants a and b in the expression for L of x. Okay, and they give us the form. Okay, so I'm going to start by saying L of 2. Thank you. L of 2 equals a plus b ln of 2, and that, yes, that equals 3. The next equation, of course, is L of 5, and you can write this on your own. That's a great question. We have 2 unknowns and we have 2 equations. Let's see if you can figure out how to solve
We did.
either A or B. I'll give you a moment to work through them. Find A or B. Discuss with your neighbor. I do recommend again starting on the left because they're
You might have
give you a good amount of work here.
We could do like anything, basically like, we could like subtract.
Oh,
It's like, and then we get rid of A.
these
and
are
then we just have, like,
division quotient properties.
Options.
Oh, excuse me.
Second, you're saying.
I know.
You're second.
I'll use my bestest.
Okay.
B,
I think I'm getting close, yeah.
Okay, we get rid of our A's.
Oh my God.
So this is L2.
We know L of 2 is,
BL
okay, it's 3. Oh my god, oh my god, oh my god.
And
Oh my
this
god.
is
Got it.
BL and F2 minus BL.
So A plus BL and 5 equals 7.
And make sure your neighbor is onto something good here.
And then you can combine them.
Okay, okay, now ready? B. BLN 2 over 5
And then.
equals -4. I think we're getting
BLN
something.
of 2 over 5.
If we divide by B.
And then you move the B to an exponent of 2 over 5.
Yeah, okay, ready? 2/5 to the power of 3.
Yeah.
Wait, no, no, wait.
Yeah.
Wait, no.
Okay.
No.
Did you guys subtract?
Yeah, we did that.
Yeah, 2/5 to the power B or
Yeah, yeah, yeah.
5 by B.
E to the negative.
I'm gonna start with this one. Did anyone else start with that? The 7? And start with that just because looking ahead, you want to avoid negativity. Okay, so from here, what do I do?
You
Oh, yeah.
move the B.
How do I move it?
Use that
Move
property.
it to the, oh wait, power of the, 5.
Quotient.
What should I do with the B?
Quotient property first.
What's that code? Yeah, let's factor it out.
Well, that's great. You did the same thing.
No.
You did it. You literally did like the same.
So,
Yeah.
You know, some people might say that ln of 5 minus ln of 2 is ln of 3, but you know, is that right? Ln of 5 over 2, is that right?
I got her saying it's 2/5.
I never said.
And she'd probably subtract the other way if she said that. Okay, so we have this, which means that B is equal to 4 over, should we say ln 2.5? Would that be reasonable? And if you wanted to, you could get your calculator and get a decimal approximation here. We're gonna leave it like that.
It's 5/2.
It depends which way you subtract, August. It could be 2/5. If you got a -4 in there,
Okay, yeah, -4.
yeah, that's fine too. And to get A, we're going to take that value and plug it in into which one?
First one.
2.
Okay. Whichever, first one I do, first one I have here. So 4 over 2.5 times ln of 5 equals 7. So A is equal to 7 minus 4 ln of 5 over ln of 2.5. And if we wanted to, we could get a decimal approximation for that.
Always like leave it in like quotient format and then subtraction form.
Oh, there's no always. Always use your best judgment, whatever is most appropriate for the circumstance. So just keep your flexibility. Well, thank you for asking. Yes, Nia.
What's the difference between plugging it into, L of 2 and L of 5 is?
Arbitrary. Either one is fine.
Do they?
Like once you have the B, which one could you plug it into? Is that yeah, whatever you like.
I, had like 4 ln 2 over ln 2.5, plus 3 is equal to.
Yeah, you could do that too. Plus 3. Yes, you're talking about plugging into the second one, right? Yeah, that's fine. Yeah, no problem at all. And just to be complete, I'm going to write the function of the logarithmic graph that we're looking for. So it was L of x is equal to A, which is 7 minus 4, ln of 5, ln of 2.5, plus B. Admittedly, this is pretty ugly, but that's okay. There's my A plus B, so both numbers, ln of x. It's a logarithmic equation. Yes.
You wanna, if that was the 10th question, you're not correcting.
Yeah, if there were no calculator allowed, then that's all you could do.
Well, but you don't have to.
Oh, yeah, you just answered the question, A and B. Any questions? I hope that the process made sense. It's basically finding the equation like a line, except it's a little bit more complicated. Okay, last problem. Look at all this data. X values are increasing. Well, let's see. Let's use a calculator to do this. I don't think this should be done by hand.
I agree.
I wonder if you remember how to put this kind of information in.
Oh, that.
Stat. Does anyone need a calculator? One moment, let me make sure these are all good. If you want to use Desmos, you could do that too. Hey, Kel, do you have your laptop? Maybe Desmos. It's, yeah, maybe that's rather than me just clearing everything. Nathan, you have your calculator?
Yeah, I know.
I mean,
Have
kind
your
of,
laptop? Okay,
like,
that's
it's
quite
like I have
impressive.
it, but it's like.
We'll use my Debbie.
Oh. Long chain. Oh,
Uh,
the battery.
I think it works. I don't know how long it will
Do you have
work.
your laptop?
Yeah.
I strongly believe.
You can use that.
Oh, your laptop's low on battery. No, I have.
And you just use this.
Oh, okay, thank you. Great.
Thank you. Danke schön.
The spots. No, wait, do I do it with the case and without the case?
Without.
The church sign with the X, please.
Ooh, I like.
Yes.
I'm not cooking on this staff.
Oh, that's why you got Nita there.
Yeah, Nathan and I.
Nathan, you'll be outnumbered.
Alright, we need to do
Split it up, look at my stats, I don't know, dude, I hate math.
No, bro, we need to clear. How do you graph it? Okay, you have to go with that.
You have to get the regression equation. Regression equation.
Alright, bro. You want me to help you at the top?
The alpha trade.
Alright, I can't help you anymore.
You guys are hopeless.
Oh.
Our bottom.
Oh.
Get it. Okay, wait, I'll help you.
I don't know.
It's like.
And what type of regression?
Clear my thing, why'd you clear it, nines?
Whatever's appropriate.
Oh, hey, what the hell?
Wait, my calculator, it's like genius. It already had all the numbers in it.
Did you steal the numbers from mine? Is that why?
No, it already had all the.
Yeah, because they probably used it in the last.
Nathan, you
Yeah,
great.
I know.
Wait, now
It's genius. It's just a genius calculator.
like up.
If it's up, then.
Yeah, what?
These are evenly spaced outputs. But they are
Hi, Augie.
kind of even.
I'm sorry.
It's a little unclear, isn't it?
I'm just thinking.
Oh, I guess I really.
Should I stick with logistic? Logarithmic?
Error.
Wait.
I retyped in August.
So why did
I'm
the.
gonna just say, is logistic the same as logarithmic?
No.
They're not five.
Good question.
What type of regression was
Wait,
it
we get
again?
LN.
I'm gonna just do LN.
LN regression?
Where's log? There's logistic.
That's not the same thing.
A
LN.
logarithm.
Okay, first of all, I need to see the data. How could I best see the data? Okay, y equals.
Plot.
Oh, thank you. Make sure the plot is on. Okay, let me clear this. Okay, and I still see nothing. What's the best way to see the data? Zoom. Which is the best zoom for
That's zero.
I think.
zoom fit? We'll keep the 0 to 10. Zoom stat is what we're looking for. It's gonna keep all your data in there. Zoom stat. Yeah. Look at that.
Oh.
Yeah, no guessing, no worrying about the wind or anything. It's beautiful. I agree.
Wait, right here, seems to.
You're welcome. Yep. Anytime you're doing a stat, that's the one. Okay. Exponential, what do you think? Exponential? Quadratic graphs? Linear?
I would say log.
Log? Okay, so how do I do this?
You go stat.
Stat, thank you.
Uh-oh.
Okay, up?
No, right.
Oh, right, I do a calc and then which one? Oh, LN, linear regression, sorry, LN regression, not linear. Number 9. Yeah. Yeah, all of that. And then I just hit enter, enter, enter.
Oh, you gotta go
Got it.
to Reg
Alpha trace.
Where?
Reg EQ.
Oh, I had to
Yes.
store the regression. Alpha trace. Oh yeah, yeah. I didn't have anything in my Y, so I'll leave it at Y1. Okay, and then calculate. Okay, here's a moment of truth. Is it gonna work? It's gonna. Oh, look how pretty.
Oh, it
Look how pretty that is. Oh, so nice.
No.
And if you want to copy down that equation, of course, information is over here.
My bad. Stole away alpha trace.
It's all there.
3 decimal points.
You just need 3 decimal places.
It's not a baby.
All the way.
Oh, okay, that makes sense. Thank you. Okay, folks,
So you're doing like
that is all we got for today. Look at that.
Oh, God. Bigger fish to fry.